It's one of the things we worry about when we start looking at medical treatments. It's stuff that becomes table talk, particularly for our parents that are older. It's the primary concern that most of the older adults within our lives seem to worry about. And what is that? The decay that happens with old age. How can we go about preventing the decay with old age? Well, let's talk about that.
Warning! The following presentation contains information that might contradict what you have previously heard, or believed to be true, about how the human body works, and contains material that is not suitable for closed-minded individuals. Enjoy!
When we start looking at this idea about decay, we start looking about this idea about preventing decay. What we're really looking at is we're looking at the downward cascade of events that takes place as we age. There is some speculation that this only takes place within Western cultures. However, that's not really the case. We do see this decay throughout the world. The biggest thing that happens is that it's not really about diet, it's not really about environment, it's more about the level of physical activity we have. As we have poorer and poorer and poorer levels of physical activity, we start seeing complications with cardiac functions. We start seeing increasing oxidative stress. We start seeing reduction in muscle and bone strength and muscle and bone mass. We start seeing hormone dysfunction, hormone dysregulation, something that we've talked about in terms of non-communicable disease issues. We start seeing reduction in neurological functions, and all of this leads to a loss of independence. And that's the key that we're trying to prevent in terms of this loss of decay, where we really can't stop the decay. Decay is going to happen. But what we're trying to do is we're trying to stop the loss of independence. And one of the things we start looking at is the fact that it becomes a vicious positive feedback loop where poor physical activity leads to reduced cardiac functions, increased oxidative stress, which leads to poor physical activity. Poor physical activity leads to a reduction in muscle and bone mass, a change in hormone functions, which leads to poor physical activity, and just becomes this vicious downward cycle. That vicious downward cycle in terms of the hormone dysregulation is going to go ahead and increase oxidative stress, which is going to lead to poor physical activity, which is going to lead to loss of dependence or loss of independence. And this loss of independence is what we're trying to prevent. And one of the easiest ways we can do this is by increasing physical activity. But how does that work? How is it that we have this change taking place that's going to lead to this loss of independence based off of the decay that takes place? Well, if we start looking back and think about how we looked at in terms of the nervous system functions and the downward decay that we see with the nervous system, all of it has to deal with how the mitochondria are functioning. And the oxidative stress develops within the mitochondria that leads to what some people speculate as a type 3 diabetes, which is really just an oxidative stress issue within the mitochondria, which limits the ability for the mitochondria to function. We start seeing increased amounts of inflammation, which causes changes in tau proteins, which we refer to as a tauopathy, or amyloid proteins, which can cause dysfunction within the neurons and the way in which the neurons are sending signals. All this leads to changes in the synaptic faction and the synaptic functions that are taking place, where under normal conditions, we have a whole host of functions that are taking place, a whole host of synapses that are sending signals coming away from the neurons. However, when we start having atrophy, we start having disuse, we start having inflammation taking place, the amount of synapses that are there start to drop. As we start to have this synaptic pruning taking place, we start losing the connection points between the neurons. What ends up happening is we start having loss of neuronal function. It's that loss of neuronal function that we start looking at. We start looking at this neurodegenerative disease that we're trying to offset through increase in physical activity. And so how can we go about preventing these neurodegenerative diseases? What can we do in order to protect the neurons from having that atrophy, from having that disuse, disconnection issues that come into play? It has to deal with what's taking place peripherally in terms of our level of activity, causing changes within inflammatory signals, which is going to lead to a reduction in inflammation, an increase in perfusion, an increase in mitochondria, an increase in or decrease in reactive oxidative species, along with changes of hormones, which is going to complement the changes that we see in terms of the changes we see with the inflammation. What this does is reduces the stress, it increases the neuron firing, it increases the strength of the synapses, and it reduces those plaques, those tau and those amyloid formations that can take place. The reduction in stress and the increase in neuron activity leads to normalization of brainwaves. That normalization of brainwaves leads to a likelihood of continuing physical activity and a likelihood of further reducing stress. These compound on each other. What this does, this leads to an increase in neuron size. This leads to an increase in the number of synapses. This leads to an increase in the hippocampal density. This increases the gray matter that we see. This reduces the amygdalar density, which leads to a normalization of brain activity. All this leads to an increase in cognitive functioning, an increase in long-term memory, and a reduction in neurodegenerative diseases, particularly those neurodegenerative diseases that are going to be associated with dementia or what we like to think about as Alzheimer's-like issues. What this does is this allows us to have the ability to remember what we're supposed to do, remember what we just did, and increase the likelihood of having further independence, even as we get into older and older and older age. Now, what ends up happening, we start looking at what's taking place within the neurons, is that the more times we use those neurons, the more robust the neurons become. The stronger those neurons become, the more connections those neurons take place. And it's not just about thinking, it's about being physically active. It's about increasing the neural growth factors. It's about increasing the sensitivity to insulin, increasing the sensitivity to leptin, reducing the inflammatory cytokines, reducing the inflammatory hormones. And what this does, particularly when we start having higher amounts of activity, both in terms of coordination of muscle movement and interactions of the nervous system, is that we're allowing for Hebbian synapsing to take place. That Hebbian synapsing allows us to have better neuronal functions and stronger neuron networks retained. Something that we talked about when we looked at how does learning take place. Something we talked about how does the nervous system develop. And so when we start looking at this idea, what we're trying to do is we're trying to take that exercise, take those stimuluses coming from the exercise, cause epigenetic and genetic regulation changes that take place, where we're going to lead to an increase in the gene expression, increase in RNA expression, increase in protein productions, and the correct protein productions. What this is going to do is this is going to lead to changes in our metabolite signaling. All this does is this leads to greater synaptic connections, more sprouting of dendrites, more sprouting of axon terminals, allowing for better connections to take place. Not only that, we get an elaboration of connections. We get additional neuron connections taking place. And in some cases, not only do we get more additional neurons taking place, we get more neurons there. We can actually grow new neurons. One of the biggest misconceptions out there is we continue to lose neurons. We never actually gain neurons. We gain neurons. It's just the rate at which they grow is so slow that they do not replicate themselves fast enough to replace the neurons that are being lost. However, if we have a reduction in stress and an increase in activity, as shown here with running in terms of a rodent study, with learning and with enrichment taking place, where that enrichment is a environment that challenges the brain to stay around. Notice we get this more robust neuronal network and we get greater amounts of branching. We get this additional sprouting taking place. And it's all stemming from being physically active. This is why we can offset the neuronal decay, the neuron degenerations that take place with aging, with being physically active. Not just mentally active, not just playing the games that they say, oh, use this and you'll have the brain of a 15, 20-year-old. You have to be physically active, not just mentally active. But the other thing we have to worry about is we have to worry about bone health, osteoporotic changes that take place, where we start to lose bone density as we age. That loss in bone density, we have a kind of a magic number here of 0.9 grams within the bone mineral density issue. We want to make sure that we keep that 0.9 grams of bone mineral density around. Not only do we want to keep that 0.9 grams, we want to keep it in the trabecular bone, not just in the cortical bone. The trabecular bone gives us the ability to resist various types of loading changes that take place. Those loading changes that take place is what's going to cause the bone to fail. And we don't want the bone to fail. We want the bone to stay in its elastic zone where the bone can bend and rebound and stay healthy. The more often we load the bone, the stronger that bone's going to be. And how do we go about doing that? It's about the physical activity that we do. Walking, running, lifting weights, all those things. Now we look at it when we're younger. What ends up happening is we take this normal looking bone and we load it and we're active and we get this nice growth taking place, particularly within the trabecula, but we also get it within the cortical. We get greater cementation layers taking place in the bone, and that makes the bone stronger. That strength in the bone is going to make sure that the bone doesn't break. And so what happens is that when we're younger, we go from having a normal bone to having this big, strong, robust bone. That big, strong, robust bone, that hypertrophied bone that's there. Now, when we're older, we're not working out in order to keep that bone hypertrophied. We're working out to prevent atrophy. And the key here, and this is where we have to look at, why do we see gender differences in terms of bone loss rates? Why do we see differences based off of the mass of the individual? The rate of the loss is proportional to the bone mineral density at the time of loss. Stuff we talked about when we looked at the use it or lose it phenomenons within some of the lectures. When we start looking at those ideas, what we have to remember is that it's not just the bones that are going to be there, but the muscles that are going to be attached to it. And this goes into how can we make sure that we are loading the bones correctly. It's all about what activities we're doing. Where walking is going to give us a fair amount of load. The whole idea here is we want to make sure we have between 1 and 1.5 times body mass loading the bones, particularly the weight-bearing bones, in order to keep those bones around. Now, some will say, well, my joints are hurting and my knees are hurting, my hips are hurting, and I'm going to go do the pool aerobic stuff. That's perfectly fine for activity. But we're missing out on some of the load by doing the pool walking. We can up this. We can up the load based off of how quickly we are walking. As we go from a walk to a jog and a jog to a run, we start getting more load on the bone. That loading is going to even be more pronounced when we start looking at going up and downstairs. Now, coming downstairs is more of a load than going upstairs, and it has to do with the physics of how the body's moving in space and the additive properties of the additional drop on the stair going down versus going up the stairs. But going up the stairs is going to need to have a greater concentric force being produced from the muscles, whereas coming down the stairs is going to have a greater eccentric force coming through the muscles, which means that we're going to get both bone health issues coming into play, as well as muscle health issues coming into play when we decide to skip the stairs and use the elevator or use the escalator instead of going up and down the stairs by walking. What about just kind of jumping around? What about just moving around, going to the park with the grandkids? Well, notice we can get somewhere between 3 and 7 times body mass by doing simple jumps, by jumping in place, by jumping off of a table, or jumping off of a bench, or doing jumping jacks, or skipping around, or dancing. And we'll get to why those things are important here in a second in terms of the ability to challenge the body based off of the base of support and center of mass issue that we have to worry about. But the biggest thing we can do if we are someone that is worried about bone health issues is go to the gym and lift weights. Yes, walking's fine. Yes, going up and down stairs fine. But the other thing we can do is we can use a controlled environment like the gym, and we can do squats and we can do deadlifts where we're automatically loading body mass, so automatically loading weight to our body mass. And that loaded weight is coming from the external loads that we're being asked to move or that we are moving based off the weights that are either holding our hands or placing around our body. What we don't want to do is we don't want to do this resistance exercise utilizing machines. We want to use body mass. We want to use free weights because body mass and free weights is going to allow me to move in the most natural pattern that I can. Not only is it going to keep me in a more natural pattern, it's going to allow me to move in a pattern that my body is going to allow me to move in. And that's where I have to take into account a lot of my physical limitations that I might have as I age. Going back to the idea about walking and jogging and running, a lot of people will complain about the arthritic issues that can come up in terms of walking. We'll talk about this in a couple minutes here, but it's not that bad of an event in terms of the loading issue. It doesn't by itself cause the arthritis to come into play. Something we've talked about previously in terms of does running cause arthritis in the knees? And I recommend looking at that discussion. Being active will retain muscle mass. And that's key here. We get a whole bunch of hormones, a whole bunch of metabolic regulators coming from skeleton, coming from skeletal muscle. That's going to keep us healthy. It's going to keep inflammation low. That's going to keep our pro health hormones high. But as we age, one of the things that happens is that we start to lose muscle mass. A lot of this muscle mass loss is due to disuse, what's referred to as disuse atrophy. As we age, that disuse atrophy becomes more pronounced. And so what's up happening is that under normal conditions, we go from having our prepubertal muscles to our postpubertal muscles and to our petrification muscles. When this happens, when the muscle grows, and the way in which the skeletal muscle is set up is it's set up anatomically as what's referred to as a polynucleated cell. That means there's multiple nucleuses that are controlling the skeletal muscle, and that has to do with the function of the skeletal muscle. We talked about this in terms of the anatomy of the skeletal muscle, and once again, please make sure you look at that video. And what happens is that as we age, the volume of what's referred to as the myonuclear domain, where each one of those nucleuses happen to be, stays relatively stable. The volume stays stable, but the muscle grows. And as the muscle grows and the volume stays stable, we get more nucleuses. As long as we continue to load the muscle, as long as we continue to test the muscle, as long as we continue to have the muscle produce strength, that muscle is going to stay around. However, as we start to disuse the muscle starts to atrophy. This is what's referred to as disuse atrophication. That disuse atrophy, if we go back and start to recruit the muscle again, that muscle is going to rebound and head back to its initial state. This disuse atrophy is associated with a loss in bone mineral density due to changes in growth signals coming away from the skeletal muscle and physical stress being placed on the bone. However, if I go about and start to recruit that muscle again, I'm going to go ahead and get that reversal in the muscle. If, however, I continue to limit the amount of overload, limit the amount of recruitment, and I have aging coming into play, I start to lose myonuclear domains. Not just I reduce the volume of the myonuclear domain, but I actually reduce the number of muscle cells that are there or muscle nuclei that are there. And I reduce the likelihood of getting a new satellite cell to come into place. That's sarcopenia. That is the actual loss of the muscle. Now, the disuse atrophy we can reverse. The sarcopenia we cannot. So the whole idea here in terms of preventing the decay is to prevent that step from disuse atrophy to becoming sarcopenia. And when we start looking at what are the general causes of this, we can have malnutrition issues. We can have disease issues. We can have hormone dysfunction issues. We can have loss of physical activity, loss of actual loading. But this happens over life. We will always have some degree of sarcopenic changes. But what we can do is we can offset some of that sarcopenic changes by changing some of our nutritional advantages. This is where a lot of the new research looking at creatine and creatine supplementation comes into play. Creatine supplementation, particularly for older individuals, is going to be very important. Another thing that's very important in terms of preventing a lot of the sarcopenia is that higher levels of exercise intensity, the higher levels of muscle recruitment that comes into play. But the other thing is nutritionally, protein, and making sure we have a positive nitrogen balance. And this is where we get a lot of the ideas coming into play about older individuals needing more protein than younger individuals do. And we're not talking about huge amounts. We're talking in the neighborhood of, for most healthy adults, 1 to 1.5 grams per kilogram body mass. For most older adults, 1.8 to 2 grams per kilogram body mass. And it goes into that stuff that we talked about when we looked at overfatness and the use of diet and exercise and prevention of overfatness issues, particularly if we're looking at in terms of body compositional changes. The older individual is going to match the nutrient needs for someone who is overfat trying to lose weight and retain fat-free mass, retain muscle mass. And so we have to put ourselves into a positive amino acid or a positive nitrogen balance. If I'm in a positive nitrogen balance and I have a fair amount of endurance and resistance activity taking place, I'm going to be able to maintain the muscle that's there. If I'm young, I'm going to go ahead and get hypertrophication taking place. But as I get older, the amount of hypertrophication is going to start to drop because I have competing effects on those satellite cells. Those satellite cells, which are the stem cells for skeletal muscle to allow skeletal muscle to grow. It's just like with the bone. It's very hard to get the bone to hypertrophy once we start to lose bone, but we can slow down the rate of loss. Same thing's happening here. We can slow down the rate of loss by changing the epigenetic signaling on those satellite cells to reduce the inflammatory signals coming into play, to improve the responsiveness that we have to growth hormone, to various growth factors, to testosterone, to androgens. That's going to allow me to maintain the muscle that's there, not necessarily to hypertrophy, but to offset any type of atrophication that can occur. By slowing down the intracellular signals, that's going to keep fiber size relatively stable, that's going to keep protein synthesis relatively high, that's going to minimize the amount of protein degradation, the amount of protein breakdown that occurs. By doing that, I'm going to make sure that I'm not having excessive amounts of muscle atrophy, but keeping muscle hypertrophy stable. I may not, once again, get actual bigger muscles, but I'll maintain my strength through changing my neural recruitment, by keeping my neural recruitment high, by making sure that I'm in a positive nitrogen balance, positive amino acid balance, to make sure that what breakdown occurs during physical activity is able to be rebuilt, that I'm able to maintain, not necessarily grow the tissues that we would normally see in terms of a younger muscle. Which leads to the question that we have to ask, what should we be doing? What are the exercises that are of importance when we start looking at this idea about preventing the decay? And this is where you go on to the internet, you get all of these various things. Oh, do these 10 exercises, do these 15 exercises, do this one workout. This is the one thing that everybody should do. Do these chair yoga exercises. Without understanding that it's not about what the person wants me to do. It's about what is physically best for me, what is physiologically best for me, what is going to be cognitively best for me. What am I going to want to do based off of the idea? So this is where we have to start looking at what are the things that are going to be self-selected towards me? What are the things that I will be willing to do that's going to have the best physical response in my body, the best physiological response in my body, the best cognitive response in my body? What's going to allow me to stay healthy? What's going to allow me to offset any of the changes that take place when I get older, or if I'm older, to offset the things that have happened as I become older, so that I'm able to stay healthy, so I'm able to stay independent. And so we start looking at, okay, walking on the treadmill. Walking is a phenomenal exercise. Once again, it gives me that 1 to 1.5 times body mass. But there's some evidence that says that we should do more than just walk on a treadmill. We should go out and do some running outside. We should go out and walk outside. The more visual inputs, the more sensory input I have, the better it's going to be for my neurological functions, but it's also going to be good for my cardiovascular function. It's also be good for my bones. It's also be good for my skeletal muscle. But some people say, well, I don't want to run because it's going to hurt my joints. It's going to lead to osteoarthritis coming into play. That's not always going to be the case, and it has to deal with the stuff we've already talked about. Doing relaxation techniques, doing yoga, doing flexibility training to allow to make sure that I keep the range of motion stable, so I'm able to move through the environment smoothly and easily, is going to be very important. But it's more than just that. Once again, lifting weights, doing things like deadlifts, doing things like squats. Yes, some of these exercises become scary because people say, oh, you'll hurt your back, oh, you'll hurt your hips, oh, you'll hurt your knees, oh, you'll hurt you. There is a lot of fear mongering out there about what we should not do, as opposed to discussions about what we should be doing. In order to get myself up off the ground, should I fall? Being able to push my body off the ground, doing push-ups in controlled environments, doing stable holds in certain environments that allow me to maintain what I need to maintain. How do I go about doing this? Once again, it goes back to the stuff we've talked about. It goes back to the idea about periodization. This is where we have to worry, because if I am already old, I have to worry about reaching overtraining much faster than someone who is young because they already have a high level of inflammation taking place. I need to get the benefits from the various levels of cardiovascular exercise. Those levels of cardiovascular exercise is going to change the metabolic effect that's taking place as well as the cardiovascular effect that's taking place with the exercise. I have to be able to understand what is taking place in my anatomy and use my anatomy and understand the physics that's taking place in the exercise is going to allow me to get the best benefit that I can get. It's not about doing these 10 exercises. It's not about doing this chair exercises. It's not about doing these 10 best exercises. It's about understanding the quality of the exercise that is taking place and being able to justify what exercise I'm doing based off of the cardiovascular benefit I'm going to get, the musculoskeletal benefit I'm going to get, the neurological benefit I'm going to get, and how I can go about periodizing, organizing my exercise to minimize the overtraining effects that can very quickly occur for people who happen to be older. If we start looking about this idea in terms of the cardiovascular zones, this is where we start looking at those zone 2 benefits. And once again, as I get older, working in that zone 2 in terms of cardiovascular benefit is going to offset changes that normally take place in terms of the heart dynamics, where we get changes in the left ventricle, hypertrophication left ventricle to overcome pressure differences. As I become active or as I stay active, I get that elongation taking place in the heart. I get normalization of dynamics of the blood vessels, which makes sure that, as Shav shows, in terms of endurance versus sedentary lifestyle, we're able to maintain much lower blood pressures. And by maintaining much lower blood pressures, we're able to maintain proper kinematics of the heart. And by able to maintain proper kinematics of the heart, we're able to offset any type of atherosclerotic changes that might take place, any type of coronary disease that might take place, independent of any changes in diet. One of the things we want to look at in stuff that we pointed out in the Diet and Exercise for Weight Loss and Improvements in Health book is that the more active I am, not only am I going to get changes in the muscle strengths that are taking place, not only get changes in the bone strength that's taking place, not only get changes in the neuron strength, but I'm going to start seeing changes in what's occurring energetically, metabolically. As I am active, as I stress the muscles, I start to develop ischemic factors, what's called MIFs, muscle ischemic factors. There are a whole bunch of different types of ischemic factors, but we're really focused here on exercise in the muscle ischemic factors. Those muscle ischemic factors can be some of the things that trigger some of the pain receptors that we get when we are exercising too rigorously. But what this does long term is it changes the way in which I do metabolism. It changes my lipid oxidation. It makes me become a better fat burner. It makes me more aerobically fit. And it does that by changing the density of the mitochondria. It maintains mitochondria, what we call mitochondrial biogenesis. One of the things we look at when we look at that neurodegenerative effect, one of the things we look at in terms of loss of endurance as we get older is we start to lose mitochondria. By being active, by increasing the signals for ischemia, we trigger the mitochondria to stay healthy. And by triggering the mitochondria to stay healthy, we're able to maintain aerobic fitness. We're able to maintain endurance. We're able to be good fuel users. And we're able to maintain our overall metabolic health. We start looking at the idea about periodization, the idea about resistance exercise. One of the things we want to do is we want to work through the various levels of exercise intensity for resistance exercise. A lot of the programs that we see online are all taking us into that very light local muscle endurance. That's great for keeping those mitochondria around, but it's not great if I want to maintain bone health. It's not great if I want to maintain muscle mass. That's where I want to work in that medium to heavy load. I want to work 50 to 75% of my maximum intensity in terms of level of resistance, working through as much of a range of motion as I possibly can work with that load, but then modifying the load to work through the entire range of motion. Where I'm looking at my rest intervals, For young individuals, that 90-second rest is perfectly fine. However, as I get older, even at a medium to medium heavy load, that 50 to 65% load, I may need 3 minutes of rest in between sets simply because of the metabolic effects that take place as I get older. But what I'm getting in return is hypertrophying signals. And that hypertrophying signals is going to allow me to maintain muscle mass, allow me to maintain bone mass. By maintaining muscle mass, by maintaining bone mass, I'm able to maintain my independence to move. But it's more than just what I am moving and it's how I am moving. And so we have to start looking at challenging my center of mass to my center of gravity, my base of support. When we start looking at the way in which we move around the environment, very rarely are we stable. And one of the things we have to worry about as we get older is falling. The biggest fear that most older individuals have is a fall leads to a break leads to a hospital stay, and a hospital stay leads to a loss of independence. What we're trying to do here is we're trying to challenge, where is my center of mass relative to my center of gravity? What is my base of support? And this is where we can utilize exercise. This is where we can utilize physical activity to challenge myself, to put myself out of a stable base of support while I'm doing movements. This is where people talk about doing one leg stance. This is where people will talk about doing one leg RDLs, Romanian deadlifts. This is where people will talk about doing single leg stands. This is where we will talk about doing single leg squats. Some people say, oh, you got to do pistol squats. Oh, you got to do Bulgarian squats. You don't have to do those fancy things. You can do simple lunges. You can do simple one leg stands. You don't have to do a whole bunch of complex exercise in order to challenge your base of support. But you have to challenge the base of support. You have to be able to maintain the various dynamic proprioceptive, vestibular, and visual senses that we have that allows me to know, how is my body oriented? How is the environment oriented around me? And how am I moving in that environment? By being able to challenge yourself in a controlled environment like in the gym, you're able to make sure that you can transition from what we take in the gym to what we do outside. Where as we get older, we start to lose some of that proprioceptive feedback. And one of the things that happens as we get older, we start losing the proprioceptive feedback is we start to look where I am stepping. As I start to look where I'm stepping, what's happening is that I start to change my center of mass and my base of support. It limits my ability to have rotation as I walk. It limits my ability to twist and turn. It limits my ability for my pelvis to do what the pelvis needs to do in order to allow me to have steps, in order to allow me to walk. By challenging the base of support, by challenging the ability to control my center of mass and my center of gravity, what it does is it allows me to keep a erect posture. It allows me to keep my shoulders back, my head up, so that I'm able to see the environment, not look at the ground. By being physically active, by keeping the mitochondria around, by keeping the nervous system around, what it does is allows me to continue to have good proprioceptive feedback, so I can feel the ground. So I know where the ground is, so I know that when I touch, I can touch, and I can go ahead and take another step. Where I don't have to look where my foot is. And since I don't have to look where my foot is, I'm able to look at everything around me. I'm able to move through the environment. And this is where, for older individuals, joining a walking club becomes very important. This is where we go back to walking is an excessively functional exercise. Walking is an amazing exercise, particularly for older individuals. And when we do it in a walking club, it increases the social availability. It increases the socialization of exercise. And if it's the group that I like, it's going to make me want to do the exercise more. And that's the key here. You want to make sure that you want to do the exercise more. The idea about preventing the decay is that we cannot actually prevent it, but what we can do is we can slow down the rate of it. By slowing down the rate of decay, we're able to maintain my level of independence. I'm able to offset the reduction in cardiovascular function. I'm able to offset the reduction in muscle mass, the reduction in bone mass. I'm able to delay the loss of the mitochondria. I'm able to delay the oxidative stresses. I'm able to delay hormone dysfunction, hormone dysregulation, which leads to inflammation. And by doing all of that, I'm able to maintain my independence. I'm able not necessarily to prevent the decay, but I'm able to delay the decay. I'm able to keep my independence much longer than what most people would want me to be able to do. Well, thanks for listening. Hopefully, got a little bit out of the conversation. Hopefully, got some interesting tidbits to raise. If you like what we're putting out there, please make sure you subscribe. Please make sure you're sharing. Click the bell to get alerts on YouTube. Give us a big thumbs up if you like what we're putting out there. Give us a big 5-star rating if you like what we're putting out there. If you have questions or comments, please make sure you leave it for us. We're more than happy to cover it in future discussions. Please make sure you follow us here on YouTube as well as on the podcast. The written stuff is Substack, the quick takes on Instagram and Threads, and now on Bluesky.